Hello, and thanks for using TickBoom, a free service that helps high school students with their math problems. For this question, a student has asked for help with question E specifically. So here we've got a classic roots of unity question, so complex numbers. Part A asks us to find the seventh roots of unity. Then we've got a whole bunch of other things that are asked in part B, C, and D. And then for part E, we're asked a certain cubic equation has roots alpha plus alpha to the 6, alpha squared plus alpha to the 5, and alpha cubed plus alpha to the 4. Use the relationships between the roots and coefficients to show that the equation of this cubic is x cubed plus x squared minus 2x minus 1 equals 0. So this is what the student has asked for help with. Now, I think to be able to work through this final part of the question, it's important to have at least done part A. So whilst the student didn't need help with this, I've laid out how I would have worked through part A, just because we're really going to need to refer to all of these roots here. So you've probably seen this before, hopefully. There's many other questions on my channel where students have asked questions requiring this, which you could go take a look at. The basic idea is that for roots of unity, you've got some complex number z to the power. So with seventh roots, it's to the power of 7. It's equal to 1, unity. You let z equal cis theta. You use de Moivre's theorem. And you eventually work out all the values of theta that would satisfy this equation. It's then typically helpful to plot them onto a unit circle, and at least for our purposes, what's really going to come in handy is just taking note of all of these roots. So alpha is cis 2 pi on 7, alpha squared is cis 4 pi on 7, and so on. We're going to basically need to plug these into our calculator to kind of get to where we need to get to. So we'll keep this as a reference, but what I'll do is I'll turn over and we'll start to tackle the final part of this question, which was all about the cubic. So basically, if we think about our generic cubic as being ax cubed plus bx squared plus cx plus d, essentially we want to find what are all these coefficients a, b, c, and d. Now, we've kind of been told what the roots of the cubic are. So maybe what I'll do is I'll let the roots of the cubic be P, Q, and R. They're just letters I'm going to designate for those roots, and we'll work them out later. But if I just for now call them P, Q, and R, then what we can say is the whole idea of roots is that you could then factorize your cubic into x minus P, x minus Q, and x minus R. And that's going to be true for any polynomial. If you had a quadratic, a cubic, any order of the polynomial, if you have all of the roots, you can write it as x minus each root all multiplied together. So that's one way to write this cubic. The other way is the way I've just noted here, the generic way. So by definition, those two things we can set equal to each other. Ax cubed plus bx squared plus cx plus d. Now what I think will be helpful is if we expand this left-hand side and do some equating of coefficients, we can get A, B, C, and D in terms of P, Q, and R. And because we know what P, Q, and R are, we were told what they were in the question, at least in terms of alpha plus alpha, I think it was alpha plus alpha to the 6, and then alpha squared plus alpha to the 5, alpha cubed plus alpha to the 4. So they're going to be our three roots. We can then calculate them because, as I mentioned, we know what all of those alphas are from doing part A, which I did in advance. All right, well, let's expand this. Maybe what I'll do is I'll leave the x minus p for now, and I'll just expand this bit. So we'll have x squared minus rx minus qx plus qr. That's all going to be ax cubed plus bx squared plus cx plus d. So far so good. Now I'll expand this bracket in. So we'll get x cubed minus rx squared minus qx squared plus qrx. So that's the x going through. Minus px squared plus prx plus pqx minus pqr. So that's the minus p going through. So that's all still going to be equal to ax cubed plus bx squared plus cx plus d. And now I might clean this up a bit just to get all the x cubes, x squareds, and so on together. So we'll have, there's only just the one x cubed here. And then maybe what I'll do is I'll do minus, and we've got a p, a minus p, a minus q, and a minus r all in front of x squared. So I'll do p plus q plus r x squared. So we've done our x cubed, we've done our x squared, so now we're up to our x's. So we'll go plus, and we've got a pq, a qr, and a pr. So I'll go pq plus pr plus qrx. So that deals with these. And then we've just got the minus pqr left. So that's ax cubed plus bx squared plus cx plus d. Alright, now we can equate our coefficients. So here I can see a must be 1 because there's just 1 in front of the x cubed. So therefore a is equal to 1. B is equal to what's in front of the x squared, which in this case is negative p plus q plus r. C is equal to pq plus pr plus qr, and then D is equal to negative pqr. Alright, so hopefully you've followed along with that. It's quite a kind of longhand way to do things, but I think it kind of gets you there, and hopefully it makes sense in terms of we're really just equating coefficients. So now we've got all of our coefficients in terms of p, q, and r. So let's go and find what p, q, and r are equal to. So remember that our first root, which I've called p, is equal to alpha plus alpha to the 6. That's what we're told in our question. So let's go and remind ourselves. Alpha was cis 2 pi and 7. And alpha to the 6 was cis negative 2 pi and 7. And notice it's the two conjugates, and that's no accident. There's a reason for that we'll see. So let's just write that in. So that's going to be cis 2 pi on 7 plus cis negative 2 pi on 7. Now, I'm going to just go ahead and say that I know that is 2 cos 2 pi on 7. And how do I know that? Well, I know that because maybe what I'll just write up here over to the side. If I was to look at cis of x plus cis of negative x, which is essentially what we've got here, well, that's going to be, if I write that in longhand, that's cos x plus I sine x plus cos of negative x plus I sine of negative x. So that's going to be cos x plus I sine x. Now this cos of negative x can then just become cos of x because of the even nature of the cos function. and the I sine negative x will be minus I sine of x. And that allows us to cancel out these imaginary parts, and we get 2 cos x. And that's a result we're going to be able to use for all of our roots, because as we'll see, they're all summing up a complex conjugate results. So that's how I could go straight from this to 2 cos 2 pi on 7. So that means Q will be equal to, well, we're told it's equal to alpha squared plus alpha to the 5, which, coming back to what I worked out earlier, another set of the complex conjugates. Alpha squared is cis 4 pi on 7, so that's going to be cis 4 pi on 7 plus cis negative 4 pi on 7. And again, using this result, that's going to be 2 cos 4 pi on 7. That's Q. Now we need to do R. I might just turn over for that. So R is going to be equal to, we're told it's alpha cubed plus alpha to the 4. So that is the last remaining pair of complex conjugates. Alpha cubed is cis 6 pi on 7, and then cis negative 6 pi on 7. So cis 6 pi on 7 plus cis negative 6 pi on 7, and again that's just going to be 2 cos 6 pi on 7. Alright, so let's just plug these in. So coming back to our coefficients, we've already got A is equal to 1, which is comforting because we're trying to get to a cubic, which I didn't actually note, but I should probably note what we're trying to do is show that the cubic is x cubed plus x squared minus 2x minus 1 equals 0. That's the cubic we're trying to show, and the coefficient of x cubed is 1 in that result. So getting A is equal to 1 is a good sign. Now let's see what we get for B. I mean, we kind of know it's got to be 1, but we need to show it. So let's go and throw in our values of P, Q, and R. And it's actually negative P plus Q plus R. So therefore what we can say is B is equal to negative P plus Q plus R, which equals negative, and P is 2 cos 2 pi on 7, 2 cos 2 pi on 7, plus Q, 2 cos 4 pi on 7, plus R, 2 cos 6 pi on 7. Alright, now, you know, people smarter than me might be able to use their superior knowledge of cos to kind of simplify this without a calculator, but I'm just going to get my calculator and plug this in because I know it's going to simplify. If I've done my job properly, I know it's going to simplify to 1, but just to give myself the comfort, I need to plug it in, and hopefully that's what we see. So let's just do it. 2 times cos 2 times 180 divided by 7 plus 2 times cos 4 times 180 divided by 7 plus 2 times cos 6 times 180 divided by 7. Negative 1, good, and then times negative 1 again is what gets us to the positive 1. So that's a good sign. Now we're going to do C, the coefficient C, and what did we work that out to be? So C is PQ plus PR plus QR, so PQ plus PR plus QR, which is equal to P is 2 cos 2 pi on 7 times Q. P, Q, R. So 2 cos 4 pi on 7 plus 2 cos 2 pi on 7 P times R, 2 cos 6 pi on 7 plus 2 cos, so what is this now, QR? 4 pi on 7 times 2 cos 6 pi on 7. So again, let's just throw that into the calculator. So 2 times cos 2 times 180 divided by 7 times 2 times cos 4 times 180 divided by 7 plus 2 times cos 2 times 180 divided by 7 times 2 times cos 6 times 180 divided by 7 plus 2 times cos 4 times 180 divided by 7 times 2 times cos 6 times 180 divided by 7. I really hope I've keyed everything in properly. -2. Now, that is a good sign because that is what we needed to see for the coefficient of x. So now we're up to our last coefficient, d is equal to, and what did we have for d? Minus PQR. So minus PQR, which equals minus 2 cos 2 pi on 7 times 2 cos 4 pi on 7 times 2 cos 6 pi on 7, and that is equal to minus 2 times cos 2 times 180 divided by 7 times 2 times cos 4 times 180 divided by 7 times 2 times cos 6 times 180 divided by 7 minus 1. Alright, so if I now kind of look to what we were asked to show, it's all looking good. So now we can write our conclusion. Therefore, the cubic must be, and we go a, which was 1, so x cubed plus b plus bx squared, and for us we got b is 1, so plus x squared plus cx, which c is minus 2, so minus 2x plus d, which is minus 1, equals 0, and that is the same as what we were asked to show. Alright, so that's that question done. Yeah, interesting question. I mean, you kind of had to at least do part A to really be able to do this final part. Once you've kind of got all your roots though, I think the key to this final part was just going back to basics on cubics, you know, the general format of a cubic, combined with the knowledge of writing a polynomial as the product of x minus each root, and then bringing that together and just doing the hard work of expanding, and then being very careful about equating coefficients and plugging in all the details. So I think the mechanics, there is room for kind of error, but at the end of the day, because you know what you're working towards, you can always know if you've kind of made a mistake in keying things in. So the real understanding that's being tested is this first part here, being able to set that up and then work through the detail. So if you found this explanation helpful, please be sure to give it a like. And if you're someone who wants to keep their finger on the pulse with the kinds of questions that other students are struggling with, please be sure to subscribe to my channel so that you can stay in the loop. Alright, tick boom.